In this video, you'll learn to build an Android app in 5 minutes and load it onto your phone using Google AI Studio. I'm a full-stack web developer who's never made an Android app before. Let's build a low-light photography app together. I learned photography back in the day using a single-lens reflex camera. For example, I used to take cool shots like this. To get back to my artistic roots, I wanted to make an app that will let me have more granular control of the camera settings. To follow along, you'll need a desktop computer with a browser, a Google account, an Android device, and a USB C2C cable. Let's get building. On your computer, navigate to aistudio.google.com. Now let's prompt Studio to create an Android app for us. We'll enter our prompt and then click Build. Our prompt is, build an Android native app for taking low-light pictures that utilizes Camera 2 API manual controls to reduce image noise. So now you can see the agent sketching out a list of initial requirements using Gemini 3.5 Flash. Now this is going to take a few minutes, so now's a good time to stretch, grab a coffee, and come back in a few. While the agent is building our app, we have a little time to zoom out a little and consider the modern mobile ecosystem. If you want to build an app that's usable on a phone, native apps are not the only option. Progressive web apps, or PWAs, have been around for a while, but their capabilities have improved significantly in recent years. Let's break it down. A progressive web app is a website that looks and behaves like a native mobile app. PWAs in 2026 support more features than ever, including WebAuth and biometrics. PWAs can natively call Android's biometric sensors for fast login experiences, like using your face or your fingerprint to authenticate. Hardware APIs. Web Bluetooth, Web NFC, and geolocation APIs give web apps direct communication with smart hardware and scanning devices right from the browser engine. File system access. PWAs can read, edit, and save changes directly to files on the user's local Android device storage. App Store distribution. You can package and monetize PWAs in the Play Store, which is also useful for app discovery. Cross-platform compatibility. The same PWA can be run on different device types, although Safari still has some limited features compared to Chrome. Now, everything in engineering is about trade-offs, and there are also strong reasons to consider building natively for Android. Here are 4 reasons to build a native Android app in 2026. Number 1, advanced background processing. If your app requires persistent, uninterrupted background data syncing, real-time location tracking, or long-running tasks, you're going to want to take advantage of advanced background processing. Number 2, deep OS and hardware hooks. Native Android apps have low-level access to the device that web standards deliberately block for security reasons. Number 3, high-performance graphics and on-device AI. You can run machine learning intensive models directly on the device for real-time responsiveness and enhanced privacy. Number 4, cross-device portability. Android native apps allow developers to more easily venture beyond phones and into other device types such as Wear OS, foldables, tablets, and Android Auto. Since our low-light photography app requires deep hardware integration for fine-grained camera control, we are going with Android native. Now let's fast forward a little bit. AI Studio lets us test the Android app in an emulator. Since this app uses native camera hardware, we do need to get it onto the phone to test it. So we're going to sideload the app, which means downloading the executable file directly onto a phone. If you have a developer account on the Play Store, you can upload the executable file there instead. But sideloading has fewer steps and is generally easier for testing while an app is still in early development. Get out your phone, open your settings, navigate to About Phone. Find the build number, which is sometimes hidden under software information, depending on your device manufacturer. Tap it 7 times in a row. Put in your PIN code if prompted. Then go to Settings, System, or Developer Options, and toggle on USB debugging. That will let us transfer the executable file directly to the device. Plug in the USB cable, open Google AI Studio Build panel, locate your app, click Install on Device, and the app will automatically download and launch. Now the moment of truth. Here's a photo I took. Not bad. AI tools have improved a lot, but it's still really hard to build something perfect on the first try. Initially, there was a bug with the photo orientation. The viewfinder showed my photo in the correct orientation, but the photo was rotated sideways when it was saved to the file system. I went back to AI Studio and prompted it to fix the issue. So after we do this, we need to sideload the new app on the device again. It automatically replaces the old version of the app. If we want to add any new features or fix any more bugs, we can keep going back to AI Studio, run another prompt, sideload the new version of the app onto our Android device, test some more, lather, rinse, repeat until we are happy. AI Studio is designed to work without the need to read the code directly, otherwise known as vibe coding. However, if you want to get more hands-on in the code or publish your app to the App Store, you can export AI Studio projects to Anti-Gravity or Android Studio. Thanks so much for following along. If you'd like to vibe code an Android app with AI Studio, go to aistudio.google.com.